All right. So good afternoon and good evening to you all. Um, Trust we are all doing well. Unfortunately, today I can't be with you. So I recorded this video so that we can have a good time um, with our practical session. Okay. All right. So let's kickstart. We are looking at user-defined functions. User-defined functions. Now, if you remember from beginning of the semester, we started looking at, or we talked about functions and function, hyperbolic functions, and even whilst we were looking at chapter 2, we also talked about the predefined functions or built-in functions. Okay, so this time around we are moving on to look at user-defined functions. Okay. Now, in engineering, in mathematics, we work more with formulas. Okay, so these formulas are user-defined expressions for calculations. Okay, and these formulas are transformed, okay, into what we call functions. And these functions can be built-in functions or uh, uh, or can be predefined formulas, okay, which are designed to uh, simplify task. Okay. Now, in this particular topic, we are going to look at how we can write formulas, okay, as functions in Matlab. How we can transform our formulas into functions in Matlab. Okay, just like some of the predefined formulas we've seen. So for instance, we use formulas or functions like finding the size of a matrix, the length of a matrix. I think our last meeting, face-to-face meeting, we did something regarding the tan function. So there are parabolic tan functions and so on. All those functions are inbuilt. They are predefined. Okay. And what it also means is that there's a formula behind those functions. So in this course or today's lesson, we are going to take some few formulas and see how we can write them as function in MATLAB. Okay. Now, function files are M files. Okay, we saw how to use the editor in our last meeting. Are M files. Okay, and they start with the word function. They start with the word function. Okay. Now, what are functions? Like I said, um, they are basically formulas, okay, which are written in program, okay, or built into program to simplify tasks. They can even exist independently from independently to perform specific operations. Okay. Now, some benefits with the use of function is that they are independent testing of subtasks. Okay, so when you write a function, it can be somewhere independent. However, when you want to use it, you call it into your program and then it performs the task for you. And so, for instance, you want to um, find the volume of a cylinder. Okay, and you notice that in writing your code, there is no particular built-in function which can help you perform that task. Okay, help you perform that task quickly. Okay. So if you have this user-defined function, you build this function as a formula, then you can have it there somewhere in your application, and then when you are solving a problem that requires you to include such a formula, then you call the function into your program to perform that task for you. Okay, so it is also a reusable code, and then it's isolated from unintended side effects. Okay. Now, in Matlab, the syntax here shows how we write formulas. Okay, sorry, how we write functions. So first you have the function, the keyword function. Then you have your what we call the output argument. So your output argument here simply means your output variables. Okay, and last week we looked at the input variable, giving a formula how to identify the input variable and then the output variable from the formula. So you specify the function name, the function over here, which is it's a keyword. Okay, so it's a keyword, it doesn't change. It starts with a lowercase function. Then you specify your output arguments. Okay, so it could be one argument, it could be multiple arguments. Then your equal to, then you now specify the function name, which could be any name at all you are giving to your your function. Okay, so for instance, if I'm finding volume of a cylinder, okay, I can give it a function name, volume of a cylinder or volume of cylinder. Okay, or I can shorten it just like we saw in our previous class, shorten it to make it give it a sensible or reasonable name, okay, from the task that is intended to solve. Then you also specify, after the function name, you specify your input argument. Your input argument. Arguments are simply values that are passed into a function. So your input argument will be based on your input variables that you identified from the formula. Okay. Now take note of the brackets. We have the square bracket for the output argument, and then we have the normal bracket, okay, or parenthesis for our input arguments. Then you can come up with some comments. Then the code that's going to be executed, usually the formula is written here. Okay, and then you end with the end keyword. Okay, so let me just read through this part quickly. So the function statement specifies the name of the function and the input and output argument lists. The input argument list appears in parentheses after the function name, and the output argument appear in brackets for the left, appear in brackets to the left of the equal sign. If there's only one output argument, the brackets can be dropped. So that means that if there's only one argument, you don't need this square brackets here. Okay. Now, Matlab functions should be placed in a file with the same name, including capitalization as the function, and the file extent.m. Okay, so that's to say that the function name, which is the name you are going to give to your function from here, should be the same name used to save your file. So when you're saving the file, you save it with the function name and then you add the extension .m. Okay, so it shows the example here. It said, for example, if the function name is func name, then that function should be placed in the file named func.m. Okay. Now, the input argument list is a list of names representing the values that will be passed from the place, from the caller to the function. These names are called dummy argument. They are just placeholders for the actual values that are passed from the caller when the function is invoked. Similarly, the output argument lists contents of dummy arguments, okay, and so on. So what they're saying here is that these input arguments here, they are just variable names. So let's say you want to represent the value, okay, here as the in argument 1. In argument 1 can be the number a. Can be the number 5. Okay, maybe it's radius, so you put the radius. But that radius there, that r or a or whichever variable you put there, is just a dummy variable or dummy argument. Okay, now when you call the function, which we are going to talk about shortly, function call, when you call the function, that's you are actually invoking the function, then in place of r, okay, or in place of a, or in place of whichever variable, you put the actual value 5 over there. Okay, so that's what this statement means. Now the function is invoked by calling is invoked by naming it in an expression together with a list of actual values. So the actual value will be the value, let's say 5. Okay, so maybe you are dealing with radius, area of a circle, radius. R is your dummy argument, but the actual argument is the value of R, which is 5. The function may be invoked by typing its name directly in the command window or by including it in the script file or another function. The name in the calling program must exactly match the function name, including capitalization. Now, when the function is invoked, the value of the first actual argument is used in place of the first dummy argument, okay, and so forth. Okay, all right. So the execution begins at the top of the function and ends when either a return statement, an end statement, or an end of function is reached. The return statement or the end of function statement is not actually required in most functions. Okay. Now the only information returned from a function is contained in the output argument. Then Matlab function is a special type of M function that runs in its own independent workspace. Okay, so just read this part. Okay, so basically I've explained what functions are and how the syntax works. Okay, now let's look at the types of function as we write some programs to implement them. Okay. All right, so there are 4 main types or ways of writing a function in Matlab. The first one is when you have a function with a single input and a single output. Okay, so the example here says we want to compute the volume of a sphere. So the volume of a sphere is 4/3 times pi r cube. 4/3 times pi r cube. Okay, so let's write this in Matlab and see what will be our response. So we'll try the first one, which is a single input and single output. So we are in our Matlab environment. We want to create first create a new script or our M file. Okay. So once I click on it, the editor open with giving us the editor tab. And then I want to browse into my folder where I'm going to be saving my work. So browse for the folder, locate the folder on desktop. So CPS 227, and then open the folder. All right, so with the folder opened, now we can start writing our code. Okay, and we learned from last week that we always start with a comment. So first comment name, comment your ID, and then let's also comment what the program is about. So we want to calculate, so this is a function to calculate or compute the volume of a sphere. So we are calculating the volume of a sphere. Now, in this example, the volume of a sphere is given by okay, so we have this as the formula for the volume of a sphere. Okay, so it's equal to 4/3 times pi r cube. Okay, so that means that if we need our input variable is r, the radius. Okay, and our output variable is volume. Okay, is volume. So what do? We go into our program, and we've been told that we start first with the keyword function, the keyword function. So I start my function with a keyword function, and then I specify my output arguments. So the output is volume. Okay, equals, then I've specified the function name. So my function name, so I can say vol of sphere. Then now we specify the input arguments. Our input here is the radius, or r. I can leave it as r. Okay. Then anytime you write a function, you end it. So you can see what's happening here. Once I add the end to it, you see this line to show that it's a function. Okay, to link it together. To link it together. Okay. If I take it off, it gives it wouldn't work properly. So I need to add the end to it. So this is the start with the function and the end. Okay. Then in here, I specify the formula. The formula. Okay. So first, we take the output argument, which is volume, and we say volume, volume is equal to 4 divided by 3 times, okay, pi times r times r times r. Okay. So what we've done here is to write a function to compute the volume of a sphere. So you see, it's straightforward. Okay, unlike what we did last week or our last meeting, with that one, we're supposed to accept the input from the user. Okay, this time around, we are going to use the input as an argument, and I'll show you how that we can execute this. Okay, but basically, this is how you write your function. Okay, this is how you write your function. If let me see if I can locate. Okay, I don't have it here. I think we did the last example. I did it on the lab, the PC at the lab. So I don't have it here. All right. So basically what I'm trying to say is, yes, you can have your inputs here just like we did last week inside the function, and you can even have your display here. Okay. So where we did the this into bracket, the display function into brackets volume. Okay. To brackets volume. So it's going to display the volume. Okay. Now, when you finish writing your code or your program, you need to save it. You need to save it. Okay, so how do you save it? We saw that from last week. Come to your editor window. Okay, and then come to the save. Click on save. Now you see that automatically the file name, which is vol of sphere, is the same function name you gave to your function. Is the same as the function name. Okay, so make sure you don't change it. If you change it, it's going to, your program will run into an error. So leave it just as the function name. Okay, leave the file name as the function name, and then make sure you are in your folder and click save. Okay, so that has been saved, or the function has been saved. So anytime I want to find the volume of a sphere, all I have to do is to call this function name. Okay, the keyword here, the keyword I'm using here is call. So you are calling a function. Okay, so call the function by its name, which is volume of sphere. So how do we call it? You can call it inside. So maybe I'm writing another code, which will mean that I have to merge this volume of a sphere to maybe another formula somewhere. I can call it in that code or that program I'm writing, or I can come and call it inside my command window. Okay, so inside my command window, how do I do it? You can double click on this, sorry. You can type it here. You can also use the run. Okay, so when I come here and I type vol of sphere, same wording. Vol of sphere into brackets R. Okay, or in fact, immediately I bring the brackets, the opening brackets, just like you can see here. Okay, it's now, this R here is my dummy argument, like we saw from the lecture notes. Is the dummy argument. Then here it's requiring us to now enter the actual argument. That's the actual value. So R, what's the value of R? Okay, so when I start typing and I bring this, if I see this pop up, it means that I'm on the right track. But if I make a mistake, for instance, capital S, I type in small s, you can see that nothing shows. Okay, so even if it shows, it has to prompt you, okay, to follow the the case sensitivity of that variable, okay, or of that function name. So always maintain the same name as the function. So volume of a sphere. So let's say the radius is 5. So I put in 5, okay, run, and then it gives me what? My answer as this. Okay, it gives me the answer as this. Okay, now this is showing because I added a display function here. So if, for instance, I take the display out by commenting it and I run the same function again, you can see that this time it doesn't display it immediately. It just gives me the answer. Okay. All right, so that is how we implement or write a function. Okay, so that's for a single output, and then single